Oh, thanks, everyone. So, DevConf, are you guys excited for a long day of learning and knowledge? Okay, if you are, there's 4 other talks, because over here, we're just going to spend the next 50 minutes talking smack about JavaScript. So, for those who don't know, my name is William. I do work for a company called Particular Software. We are the makers of NService Bus. Has anybody heard of NService Bus? Yes. Anybody using NService Bus? Okay. I like that. I'm not talking about NService Bus at all today, but if you haven't heard of NService Bus, it is a framework and set of libraries that make it easy for developers to implement distributed systems, whether that's microservices or SOA or geographically distributed systems, whatever it is. NService Bus has got something that will make it easier for you to write reliable and consistent distributed applications. But instead of talking about that, I'm going to spend today talking about my one true love and passion, which is the Node modules folder. So hopefully we're all aware that that's a joke. Not that Node modules isn't my one true love and passion. It is. But I'm not going to be talking explicitly about the Node modules folder. It's going to feature quite heavily in all of our demos today, but we're actually going to be talking about micro-frontends. Specifically, the techniques that microservices have developed to enable micro-frontends and what we can learn from that and apply it to non-microservice systems in order to deal with legacy JavaScript. So with that out the way, let's begin. And what better place to begin than at the beginning? So 13.7 billion years ago, there was a big bang and out popped a universe. A lot of stuff happened since then, all of it leading up to one date in particular, right over there at the end of the cosmic calendar. So I've also been told, by the way, that that Pangea picture over there looks a bit like it's a flat Earth. So it's funny how the Earth went flat and then round again, and now it's going back to flat. Nature's so cool. So 13.7 billion years have led up to this one point in time. The date is the 26th of August, 2006. We shouldn't use AD and BC anymore. We should now use AJ and BJ for that separation. On the date of the 26th of August 2006, John Resig finally released jQuery to the world. Version 1, of course it was out before then. And everything changed. So before jQuery, if you were doing any web development, were any people active developers before jQuery came out? Okay, so you guys should all know that you were doing specific checks for specific browsers. And if you were like me, incompetent, you would just put a little thing at the bottom of the screen saying optimized for Netscape Navigator at 800 by 600. And then move on. But jQuery came around and it made that process a lot easier. Instead of having to worry about which browser you were working with, you could just code against the jQuery API. And then jQuery would take care of making sure that everything worked with the browser behind the scenes. And that's pretty cool. As JavaScript developers, we kind of realized, I don't think anyone called themselves a JavaScript developer back then. As web developers, we kind of realized that there was a lot of power behind the frameworks, and they could save you a lot of time. So there were obviously a lot of other tools besides jQuery. There was UE, MooTools, there were a bunch of other ones. But in the area that I was in, jQuery is by far the most dominant. And it kind of signaled that the change of an era where frameworks became valuable for developers. Now, I'm not saying it's John Resig's fault. It's also not jQuery's fault per se, but there is a lot of blame to go around. Because after jQuery, things got a little bit weird in the JavaScript space. So we've got isodd, which is a package that to this day still gets 3.7 million downloads every single week. Every single week you are downloading a package called isodd. And that's not even the weirdest one. There's one called is13. Anyone want to take a guess what it does? Yep. So I think as JavaScript developers, it's time that we have a bit of honest introspection. And we admit to ourselves that we might have a bit of a framework problem. And it's fun to make fun of it, but it's actually not amusing, because this is a real problem. If you're developing a system now, what is the lifetime of that system? Is it 6 months until Unicorn JS comes out? No, unlikely. More likely than not, it's going to be 5 years, 10 years, maybe even 15 years that you're going to have to support this system, or someone's going to have to support this system of yours, because we all know we write the first 18 months and then we move off to another company and leave the mess behind for someone else to deal with. So how do you choose the right framework now that it's still going to be actively developed in 5, 10, 15, 20 years, and still going to be able to find support for that framework? Well, the simple answer is you don't. It's not possible. There's nothing that you can choose now, unless we drastically change how we work with JavaScript. There's nothing you can choose now that's still going to be prime time in the next 5 years. But it doesn't mean that all hope is lost. So as an industry, we've actually come up with a pretty good way of getting different sets of technology to work together in one big system. And we can see that as evident in the microservices space. So in the microservice space, each microservice can have a completely different set of technology to every other microservice. Now on the back end, this is super cool, and it's super easy to do because it's just the back end stuff. But what do you do on the front end when everything has to be brought together and presented to the user? Suddenly everything has to be angle brackets, semicolons optionally, and some CSS. So what we're going to do is we're going to take a look at techniques from the microservices space that we can apply on the front end to see how we can work about this and how we can have different bits of JavaScript with different frameworks hosted in one application on the front end, and how we can bring everything together. The techniques we're going to look at today is we're first going to start with complete isolation. Then we're going to go into componentization. We're going to extend that further with web components. And then we're going to take a step back and look at having hybrid multi-frameworks within one application on the front end. And there's obviously pros and cons for each, so you'll have to decide which technique fits better for your environment. So let's begin. What do I mean by complete isolation? So if you had a monolith system and you wanted to transition the system to microservices, one approach you could do is you could start carving off bits of functionality. So you could take your entire application and take a portion of that application, extract that from the main monolith, and then host that in a microfrontends, or microservice, sorry. Too many micro words here. In a microservice component. So you take that bit of functionality, you remove it from your main application, and you host it somewhere else. And we can do the same on the front end. And in fact, you've probably seen this before. If you've ever browsed anything for Amazon, say you were looking for general relativity books for your toddlers, you would be presented with a view similar to this, where on the top you would have a navigation bar with some search information. On the side, you've got what else you might look for. You've got reviews and stars. But as soon as you go to checkout, so if you've added these items to your cart and you go to the checkout page, it's a completely different experience. The nav bar is gone. It actually looks a bit more like you're printing out an invoice more than anything else. You don't have the reviews button anymore. You don't have the what other people have bought or recommended items. So we've already got this concept of, well, we can do things completely differently. If you buy anything online, excluding Amazon, of course, and you go to the checkout process and you get redirected to your bank's portal to go and capture the information, that's exactly the same thing. You're separating the payment from the rest of the application. And we can use that technique within our existing systems as well. So let's do a few demos. So this is the ASP.NET MVC music store. It's really, yeah, it's that. So this is just a demo application. Obviously, you can go through and you can, am I logged in? Yes, so I can go and add items to my cart. Let's add men at work. And then you can check out. And that's kind of cool. If you scroll down at the bottom, there's a submit order. So if you were the developer that was responsible for working on this system, and your company had a product owner, and he came to you and said, I have an idea, which is the 4 worst words any developer can ever hear from a product owner. And it's going to be an open plan hot swap office, of course. So the product owner is going to walk in, spend 5 minutes trying to find where you are, then walk up to you. You're going to crawl under the desk and moan a bit. So I have an idea. We seem to lose a lot of people at the checkout process. Why don't we implement one-click checkout? And you think, oh man, that's such a good idea. Damn it. Because it is. It would be a good idea if you just allow people to quickly buy stuff. The easier you make it for people to part with their money, the better. But now the problem with doing one-click checkout is you're now saving payment information, or you're going to have to save payment information somewhere, which means you might have to make your entire system PCI compliant, which means your little one-click checkout, which should realistically take about a few days, is going to end up being a 12, 14, 15-month project to get the whole application PCI compliant. So why don't we separate this out? Why don't we create a completely separate application that just does the payment, and we make that application PCI compliant, and then the communication between our main application and that application PCI compliant, and then we're done. So we'll do that. We'll spin up a separate Express application. So we'll do a Node application with Express.js. No, get rid of that. And yep, that's there. And this is just a simple checkout view that I've spun up. Doesn't really matter. So instead of going, no, I need to go back. So instead of clicking on the checkout, I've got way too many windows open. Instead of redirecting to the checkout controller, why don't we redirect to that separate application? So I've deployed it locally. Have I typed in this correctly? Checkout, and we pass through the cart ID equals whatever. So now when the person clicks the checkout button, once it refreshes, come on. Okay, so now when you click the checkout button, you get redirected to a separate payment application. Okay, sort of cool, whatever. We can also use this technique slightly differently. So let's take that out. And instead of redirecting to a separate page, we can take our checkout page. Now, let's comment that whole thing out. And then instead of going to a page, we'll stick this in an iframe. Everyone loves iframes, right? We'll add some styling here to make it look not awful. So border, none. I'll do that. Whatever, that's enough to kind of get us going. So now when you check out, you get redirected to a page that sort of looks like it's within the same application. It's kind of weird and awkward, but hey, it works, and we didn't have to spend 14 months writing a whole new framework to get our system working. So that's, oopsie, that's gone too far. So that's looking at isolation. So pros and cons of isolation. On the pro side, there's complete technology isolation. It doesn't matter what the technology stack of the one is, you've got a completely separate technology stack you can use in the other one. In terms of deployment isolation, you can deploy that checkout process 5, 6, 7 times every half hour. On every commit, you can deploy a new version. And your main application could be on a strict 6-month release cycle where you need code freezes and change controls and all those agile things. There's full runtime isolation, so nothing you do in the one can impact what's happening in the other unless you do something really catastrophic. And you can get some really fast load times because you're not adding functionality to an already potentially bloated system. So if the person has bookmarked their checkout page because they just want to check their information out and they're, well, I just need to check my wife before I can buy this thing. They don't have to load up all of the other modules that you're going to be loading in the rest of the application. They can just go straight to the checkout page. Cache management is really easy, again, because you've got no overlap between the two systems. On the downsides, there's no code reuse. The branding identity is really bit weird. You have to share style sheets to get things to look the same. And from a user experience perspective, it is a little bit clunky. If we do server-side includes, so we can put things like the nav bar, the sidebar, the footer, some style sheets in. We can get some of the code reuse and brand and identity there, but it's still not going to be perfect. If we look at embedding it within an iframe, you can get slow load times there, but you get a better brand and identity and a smoother user experience. So the reason you could get slow load times is that every time the browser renders the markup, it only goes and makes a request for the iframe content once it actually sees there's another iframe it has to render. And if you've got a high latency network, that's going to be very visible for your users when they're using your system. So you do need to be aware of that. This does work really well in some situations, though. So has anyone used the Spotify desktop application? Right, that is basically a C++ app with about 1 million different iframes inside of it. It's really powerful because it allows their teams to iterate fast on different technology choices for themselves. They've got control over exactly what technology and stack they're using for their component, but it doesn't impact the rest of the application. And it works really well, obviously, because it's just in-memory communication. There's no latency between making a request and getting it back. Or obviously, there's some latency, but it's very low. So from here, we're now going to take a look at componentization. So we've taken a look at just deploying things separately. Now we're going to spend some time looking at bringing things together into one application. So before we do that, we're going to have a 3-minute primer on node modules. That's the one. Okay, so this is a package.json file. So when you npm init or yarn init a new application, you get kind of some template like this. So the section over here, the dependencies, this tells you what your application needs in order to run. These are the libraries that it needs. There is also a dev dependencies. Which is a very similar syntax. The difference between dev dependencies and dependencies is semantic. Dev dependencies is only for development time, whereas dependencies are these are going to be shipped into production. So to add a dependency, all you do is in your node file, you either yarn add or npm install, or you can do it manually. So we're going to add the is13 library here, and we'll just go for version 1.1.0. And if I now npm install, it's going to go and download that package, add it to my node modules folder. So it should now be, yeah, there's my is13 with the most amazing syntax you've ever seen in your life, which is an entire package on its own. It's great. There's no problem here. So that's how you import dependencies into your system. How do we export dependencies? So let's say we were making a package that we wanted to export. How would we do that? Same thing, it's in the package.json file. We just look at a different place. So instead of messing about with the dependencies, we're now going to look up at the top here. So we've got the name of our package, which is Express Checkout, because it's a Express.js application and we do an Express Checkout. Oh, wow, guys, if you don't like that, you're in for the longest 40 minutes of your life. So when you go npm install, the Node Package Manager is amazing. You can npm install pretty much anything. You can npm install a package from the Node repository. You can npm install a package from a file system folder, from a GitHub repository, from a website, pretty much anything, really. I wouldn't be surprised if you can npm install a fax message. But the way that it knows what to do, so if it's on the npm repository, or if it's on a GitHub repository, if it's on a file system, is that it looks at the package.json file, and it says, well, tell me about this package. What must I download and install so that I can run? And the first thing it looks for is a main property. So the main property says, when you install this package, the first thing you must do is this is the main file that must come down. So I'm going to say the app.js is the file that must get downloaded when someone npm installs this repository. If there's additional files that have to be downloaded, they belong in the files property, which is an array, and this just takes, so app2.js, you could add app3.js in strings, of course. So the main and the files property, or attribute, are the ones that tell npm, look, these are the files that when you npm install this repository, you must download these files, put them into the node modules directory so that the application can then use them. So that's it. That's how you expose dependencies with Node. There's a bunch of other attributes on the packages.json file, package.json file. But for what we're going to do today, we don't need anything other than these. So let's go to this application. So Tours R Us. So this is an application that allows you to search for, I need to scroll down because the resolution on these projectors is huge. So you can search for flights, hotels, and car rentals. Now, the company that we work for develops the system, and it's been a very successful company, not like other tourism companies, which, thanks to the internet, seem to not be doing all that great anymore. But they've done really well, and they've also bought a cruise application, or cruise company. And the product owner comes to us and says, I have an idea. Under the desk, cry for a bit, come back out and say, yes. The product owner says, it'd be really nice if we also allowed people to search for cruises within this application. Now, has anybody ever worked in an industry where you have to do any kind of travel arrangements? I know we've got at least one flight person here. It's a disaster. It is not a pleasant experience. Thankfully, though, that cruise company that we bought already has an application. And this allows you to see the cruises that you've booked, where you're going to stop along the way. So this one's from Gdansk to St. Petersburg. And you can see kind of tourist things along the way in the ports, and this is an Angular application, and our main tourism application is a React front-end application. So somehow we need to integrate the Angular application into our React application. And we're going to do this in a couple stages. So we're not going to go straight into throwing Angular and React into the same application. That's coming. We're first going to take a look at what's called autonomous teams. So if you're in the microservice space and you're implementing a particular microservice for a bounded context, the implication is the team that's working on that bounded context has all of the skills and knowledge required to develop everything for that bounded context. So that means the database, the back end, the services layer, the communication protocol, all the way up to the front end. So if your application was a mobile application, your team would have to have the skills to do both an iOS application as well as an Android application, assuming those are the targets that you want to support. If we take that to the JavaScript space, what that means is the team that's implementing each component has to be able to deploy that component in the technology that it's going to be expected to run in. Which means that from our Angular team, and I'm going to probably get it wrong and call this the Cruise team, but okay, Cruise Angular team, they need to be able to give us a component that can be deployed within our React application. So let's take this step by step. What does our React application look like? So essentially, the React application is just some silly markup where we've got the nav buttons. So we've got the hotel nav button, the car nav button, the flight nav button. And this just allows each of these teams that's responsible for flights to decide what that little emoji must look like and what the text of the nav button is. Then there is also the flight component, the hotel component, and the car component. What this allows is for the teams to implement their own search criteria here. So they can decide, well, what's important to be able to search for a hotel. Once you click the Find Hotel, this search component knows which backend to talk to, and it knows how to talk to its own backend. Okay, so this is how the React application has been structured. So what we need to do, essentially, is at the top here, where we're importing these different modules from the different files that we're working on, we want to do something similar, but instead of a car, we want to import a cruise and a cruise nav button from somewhere. Now, where are we going to get that from? So we're going to make, initially, the Angular team give us those components. Okay, so if we go to the Angular application, that's that one, yes. Okay, so here's our Angular application, which is, there's our map controller. It's got a header in, it's got an XMap thingy and some stuff, whatever, irrelevant. If we look at our package.json file, all of our dependencies over here are for Angular because that's what our application is run with by default. But right at the bottom, I've added some dev dependencies. And these dev dependencies are for React. So at development time, we're going to expect our Angular team to create a React component for us as well. And they've done it exactly the same as the as the React team. They've gone and created a cruise nav button because we've told them this is what it must be. And they've gone and created a cruise component which talks to its own backend. So this component, the search control, the cruise control, if you will, knows how to talk to its own backend. So we've got this cruises.js file, remember, and we want to export this somewhere. So this application has got its own GitHub repository, and the previous tourism application has its own GitHub repository. So if I commit this to my repository, the way that I expose that cruise.js file, remember we said it's the main property within our package.json. So I've said, when you build this application, take the build static.js cruises file and include that in the package. So when I go to the package.json for this one, you can see I've added a GitHub reference to this package, which is on my GitHub repository. And it's the Microfrontend cruises module, which means in my main application, this is the file that gets downloaded. So there's my Microfrontends cruise node module, the build static.js, and there's the cruise package, or the cruise.js file. And if I want to display this, it's that one. Instead of importing a cruise and a cruise nav button from a file, I'll be importing them from a module. And the module is going to be the Microfrontends cruises module. The package manager that I'm using here knows that if it's in the node modules folder, I know how to get that information out of it. Which means when we come down here and we stick down a car nav button, we could replace this with a cruise nav button. Cruise. And we'll copy paste that. And we'll do the same for the actual search control. I bet you all came here to watch me type. So cruises, this is a cruise and a cruise. So this comes from the package that has been exported by the Angular team. It's a React component for now. And when we reload our application, we should see we've now got the cruises tab over there with its own component. So that means that the Angular team, they can update this cruise package, and every time they commit and push it to their GitHub repository, in my React application, when I update that reference and I pull the next version, I'm going to get the updated component that they're using. So that's the first look at componentization. If we're looking at the pros and cons of each, there is no technology isolation at all. We had a React application. The Angular team must give us a React component. Not even just a React component, they must give us the same major version of React. So semantic versioning is very important here. If you've got major version changes, that's not going to be compatible, or it might not be compatible. If you've got minor or patch version changes, it should still be okay, depending on what the changes are. There's no runtime isolation because you're literally loading it within the same front end. There's slow load times because you are asking a team that doesn't necessarily know the technology stack that you're using to implement in that technology. So they could implement a really inefficient approach. They could also have their own frameworks that they use and that they depend on, which means those are all going to have to be downloaded into your application and shared in the browser. So you can get some pretty bad load times here. Cache management is fairly easy though, because you're being very explicit about the versions of all the libraries that you're using. You get some really cool code reuse, which I've put here as a positive, but if it's my code, you might not actually want to reuse it. And then there's a very nice shared brand and identity, and the user experience for the users is seamless. To them, it feels like it's all the same application, because it is. Let's extend this a little further, though, and let's have a look at web components. So instead of having a component in React hosted within our React application, let's bundle up an Angular component as a web component and host that inside our React application. So as I showed you earlier, this whole page over here is one Angular control. The reason I've got the text welcome to cruises or us at the top is because I learned my lesson trying to do this with really bad internet once, and the map didn't display, so it looked like nothing was happening. So now the text is part of the component, and we can see that there. So this component over here has got the heading welcome to cruises or us, and then inside of it, it's got the map component. This is the Angular map component code. There's nothing really interesting here, except, so over here, we're specifying an encapsulation. And the encapsulation is to tell Angular elements, which is what we're going to use to actually bundle this thing up as a web component, that this is how this thing must be hosted within the application. So I'm using encapsulation.native, which means that it must use the shadow DOM, or it must emulate the shadow DOM when it's hosted within the main application. Yeah, so I've got Angular elements installed somewhere here. Yeah, there's Angular elements, and that's going to go and do all of the wrapping up and bundling for us. So I specify the encapsulation on the component. Then in the application, in the app module, there's a few other things we have to do there. So in the app module, I create a custom element over here, which comes from the Angular elements package. And I've defined it as map control. And what this means is that when someone's imported my web component, the way they would use it in HTML is they would say that, map control. If there were any properties that I was passing through, you would say props equals, and you would pass them through as regular properties or attributes over here. So I've created this custom map control component, and I've said that it must be based off of the map control component. And then the last thing we have to do is in the module, we have to explicitly bootstrap the entry point. We have to specify the bootstrap and the entry point to include this map control component. So that when you go ng build, it knows, okay, I need to go and build this web component for you. So when you go ng build, what it does is it spits out 4 files. And I believe it is somewhere here. There. No, not that one. Somewhere. It spits out 4 files. And instead of having to work with 4 separate files, I've gone and created a component build.js, which runs after ng build. And this goes and takes those 4 files and just combines them into one file so that it's easier to demo the package JSON stuff. So it takes the runtime, the polyfill, the scripts, and the main, sticks it all in a file called component/mapcontrol.js, and this is what it looks like. You'll notice the scroll bar isn't moving much at all. This is massive. Okay, so we've got our mapcontrol.js, and in our package.json file, so we need to export this file. So in our package.json, over here, this was our main file. I did also include the map control when I did this originally. So this map control file should have been downloaded when you npm installed this package as well. And we can see that in the, so there's my Microfrontends node module, there's my map, my component, and my map control file. So we've got this massive file that's sitting over here, and we can use it in our application. So let's do it. So we'll go to our index, and I'm just going to stick it right at the top. Go away. I really don't have the real estate for more pop-ups. And we want to display the map control. So we just stick it there as the element. Again, if there were attributes we wanted to pass through, we would do them as part of the HTML element there. Then we need to include the JavaScript file, so script, and I'm going to do it directly from the node modules folder. Don't ever do this in production. If you ship your node modules to the internet runs out of space. So you have a build tool that's going to go and import that as a module so that you can then deploy just that file and potentially optimize it a bit better than this. So we want the map and the component and the map control. And that should be it. So now if I refresh my Tours or Us application, the top portion should be replaced, or not replaced, but it should have the Cruiser or Us Angular component. And the bottom portion has got the rest of our React application running. So that's like the 4-minute primer into wrapping Angular components up as web components. Each of the frameworks have a different way of doing web components, but once it's bundled up as a web component, you just need to include that JavaScript, and then you can use it within your application as if it was a native HTML element. So let's look at some pros and cons. You've got complete technology isolation, because you can literally take Angular 6 hosted in a React application. You can have Angular 6 hosted in an Angular 4 application. You can have AngularJS 1.8 in an AngularJS 1.4 application. You've got complete isolation between the technology there. Again, there's no real deployment isolation, because no matter how many times I update that Angular web component package, it's only going to be updated in production when I pull the latest version and deploy that. There's runtime isolation because of the shadow DOM. So that's one of the nice things about web components, especially with the shadow DOM, where no matter what changes you make to the style sheets and elements within that component, it's not going to have side effects on any other components within your application. Could be good, could be bad, depending on what you're trying to share. You are going to get slow load times because that one file for that one component was 400 kilobytes big. If you're doing full encapsulation of a web component, that means that component must have all of its dependencies bundled with it. There are other ways of doing it without the dependencies, and we're going to cover that next. But in this case, if I wanted a separate component for the search and a separate component for the map, that would be 400 kilobytes at least for each of them. And pretty soon, you're going to end up with a page that's as large as a SharePoint page. So not necessarily the best approach. Cache management is almost impossible here because you're bundling up the versions of your application with the framework that you're using. So if you're changing an equal sign to a greater than or equal sign, that entire module has to be re-downloaded again. So that's another 400 kilobytes. So it's almost impossible to do good cache management here. You do get some really good code reuse. Again, good or bad. If it's mine, bad. If it's yours, good. There's a shared brand and identity, sort of. Because of the shadow DOM, the style sheets don't apply. But you do get a nice, smooth user experience between the two applications. So let's take a step back. And instead of working with Angular or React or trying to get everything together, let's try have a look at multiple frameworks together. So we're going to see two ways to achieve that. So the first is a framework called Single Spar framework. And single SPA stands for single page application, and they know that it's redundant, they just don't care. And what single SPA allows you to do is to host multiple of these single page application frameworks at one time within the browser. So this particular page, at the top we've got React, at the middle we've got AngularJS, and at the bottom, we'll have to scroll down, this resolution is amazing. You've got Angular application. And the way that single SPA does it is it looks at the URL that you're using. So in this case, it's been configured to say, hey, if I'm at the AngularJS URL, I need to load React, AngularJS, and Angular. When you navigate away, it knows how to unmount all of those frameworks from memory as well. So the nice thing about single SPA is that you don't have to worry about version conflicts. So for instance, one of the things you can do is you can have AngularJS 1.4 in the same application as AngularJS 1.8. So it's very similar to WebComponents in that way, except you don't have to download the package for each component you're using. But instead of looking at single SPA, so this is just for reference, so you can go and Google it afterwards, we're going to take a look at one of the features that they expose called parcels. Now a parcel, instead of saying, if I'm on this URL, I need to load all of these frameworks, a parcel within single SPA allows you to define which framework must get spun up, and you control when it gets loaded up and when it gets unmounted. So there's 3 lifecycle events. There's onMount, there's unmount, and the third one that I can't remember at all now. But the 2 important ones, there's 2 plus extras. We'll do that. So there's 2 plus extras, which is the mount and the unmount. And the way we're going to show that is, again, looking at an Angular application. So this is an insurance company that does crypto machine learning. I honestly wouldn't be surprised if this is a real thing. So we're going to do an insurance application, and all that this does is every time you click on one of these buttons, it pops up a little modal dialog in Angular. The one that's different is this all risk cover. So it pops up a modal dialog, but instead of a bit of text there, we've got a view component. That's been, as you open this dialog, single SPA parcel goes and says, okay, I need to mount view. I then need to pass this component to view. And then once I close this, it unmounts view from the application again. Okay, so we're going to have a look at how we achieve that in code. Okay, so this is our app component. As you can see, it's just an Angular template or an Angular control. And here is the all risk cover component. So the all risk cover, all it does, it's got the header, it's got some close button things, and inside the main body, it's got a parcel component that passes some items through as part of the attributes. The parcel component is then what goes and says, okay, I need to go and load this thing up and shut it down. The parcel component, the markup for the parcel component has got some texture, pre-div, post-div, whatever, but you never see that anywhere because single SPA goes and replaces that as soon as view is ready and loaded. The way that it loads is in the actual parcel component itself. There's my main Angular application. Because this is an Angular component, the parcel component itself is an Angular component that's been displayed. Inside the Angular component, we create an instance of something called the single SPA view. Now this single SPA view comes from the single SPA view package, which single SPA created for us, and this exposes the different life cycles that we need. So that's the mount, unmount, and the others, whatever they are. Then we've also imported view because we're loading view at this point in our application. And once we create an instance of this lifecycle object, we say we pass view to it, and then this over here, this is the actual view component all the way down to there. So we've got the template, we've got the computed functions, we've got the filters, we've got any behavior that we want. This could come from a separate package somewhere as well. This could come from a separate file. I'm doing it inline so that it's a bit more explicit here. So here's all our view behavior. There's our click. When you click on a thing, it sorts it. So if I go sort up one of these, the sort doesn't work. Search works at least. So this could come from a separate package somewhere else. So this could be a separate npm install to get these in. And all you have to do is, I say all you have to do, but what you have to do is wrap it up inside a single SPA view lifecycle. When you're ready to host it, you call mount parcel. So this now goes and triggers the loading up of view, the instantiation or bootstrapping of view, passes your component to view, renders it in that bit of template fragment that you've specified, and then tells you once it's finished loading that view. So that mount is a promise that gets returned. And then if you want to unmount it, it's just the unmount root parcel. So when you navigate away, remove view from memory so that you're not leaving it there unnecessarily. And then that's it. That's the outcome of that one. So let's look at some pros and cons of doing these parcels. You get technology isolation because you can use different versions of different frameworks in the same application. So like I said, you can host, instead of just AngularJS and another framework, you can have specific versions of AngularJS. It's one of the options you specify in those life cycles. You don't get deployment isolation again, you don't get runtime isolation again, and you don't get fast load times. So even though we're not bundling it up as a web component, the browser still has to download both Angular and Vue at some point to be able to display that information. The difference between this and web components is that instead of having to download Angular for every component or Vue for every component, it's just downloading it once and the other components are hosted using that same runtime. Cache management is also a little bit tricky here. Again, because you're sharing a whole lot of stuff, so you need to be very clear about what versions are cached and who's got access to what. You get some nice code reuse if you're trying to bring stuff together. You get a shared brand and identity and a smooth user experience. Because this isn't hosted as web components and there's no shadow DOM, you can share style sheets across, which again could be good or bad, depends on what you're after. So let's do a quick recap. What did we take a look at today? We first took a look at complete isolation, so literally just navigating to a separate application. By far the easiest and one of my favorite approaches. I was having a conversation earlier today about the demise of these single page applications, and we should really be moving towards multiple page applications again, or websites. Not everything has to be a single page application. So we navigate to an expressly different one. Someone picked it up. Or you host it within an iframe. You kind of make it look like the same thing. Worth noting, though, that OWASP does list iframes in their top 10 security vulnerabilities. So don't do this, but do it. Wink. Then we took a look at components. So we spent a bit of time taking a look at the package.json file, how to include dependencies in your application and how to export dependencies from your application. And then we saw how we can export a dependency from a different repository, bring it into our main repository. We then looked at web components, so taking something from a different repository in a different technology stack, bundling it up as its own component and hosting it in a separate application completely. We then took a brief look at the single spar, the main one, and then we looked at parcels, which is sort of like a hybrid between web components and native components again. So there's two kind of big themes that I see from this. The first is that you either host things completely separately and you embrace the isolation between them, or you kind of look at bringing things from different pieces together into one front end. And almost invariably, the bringing things together into one front end sounds cooler, but it does have a lot of problems, especially when you're trying to deal with cache management and versioning between packages. Sometimes it does make a lot of sense, though, but if you've got external-facing customers, you're probably going to run into performance issues that you want to address at some point. So each implementation has a bunch of pros and cons, and it's up to you to decide which of them fits better for your environment, whether or not something's applicable or not. You can, of course, use multiple of these, and I'm hoping that just by discussing these here, you've got ideas for other ways that you can do this, because this is definitely not an exhaustive list, and in fact, this isn't even how microfrontends are typically done. So there's no perfect answer, and I'm hoping that you guys have at least taken some inspiration away to find something that fits better for your environments if you are dealing with legacy JavaScript. There's some required reading. Please don't forget to rate the talk. It's a little known fact, but what they actually do is they lock speakers in a cage after their session, and they only let them out once they've got a few or enough ratings. So please do go rate. I'm hungry. And there's a few videos there. There's Finding Your Service Boundaries, which is less about micro frontends, but if you have appropriate service boundaries and bounded context within your systems, it makes implementing these things a lot easier because you have less crosstalk between the components that you have to worry about. And then there's single spar JS, if you want to take a look at that, the web components documentation from Mozilla, And then both of the demos that we've seen today, or all of the demos we've seen today, are in those two GitHub repositories. The Cruises is on its own, that's the Angular application, and the Microfrontends demo includes everything else. It's got the insurance, the tourism, the .NET, and whatever else you need there. And that's it. Are there any questions? If you're using Parcel, it will not be lazy, it will be explicit, not lazy, it will not be lazy, it'll be, you'll have to include Vue and Angular in your actual HTML fragment. Only when you, because when you're doing the import Vue from Vue at that stage, when you build your output, it's going to be part of that bundle anyway. If you're doing single spar on its own, you can do lazy loading with that, and the site that I showed you with their demo, that shows how to do the lazy loading themselves. Yes?
Is there any value in not necessarily looking at it from a point of view of how do you replace legacy, but right now building components with microfrontends in mind? So instead of just doing for legacy, but doing it for new websites, which will make it as simple as possible, as simple as possible in the future?
Maybe. Don't prematurely optimize though. So it could make sense, and having things as nice components that are isolated and self-contained is a great idea. I wouldn't necessarily go and make everything a web component or a parcel or anything like that. It really depends. It's a it depends kind of thing. I'm getting a look from Mike that he disagrees with me, but that's okay. One of us is wrong. Right, any other questions? Otherwise, yes. Oh. Sorry, can you repeat that? I have not.
Microservices, how could you use it when changing the front-end things?
How could you use microservices when changing the front-end things?
Yeah, when it's not just colors, but also positioning.
Okay, so if you're building up a microservice front-end, right, you'd have to have some type of what we typically call an IT ops service. And that IT ops service is what defines what all the different pieces that are going to be brought together must conform to and kind of what structure they must have. So this applies both in the back end and the front end. So the IT ops service would define your components must be this kind of size. If it's going to be part of the nav bar, it must conform to this. If it's going to be displayed in the main content area, it must be this. If it's going to be used in this manner, it must be this. There has to be that understanding of conforming between what the IT ops shell requires and what the component provides. If a component sense gives you something that doesn't conform and breaks the rest of the layout, that should be a bug, and that should be addressed as that. I don't think there's a way that you could make everything just magically fit unless that IT ops shell has been implemented in a way that allows for that as well. Okay, if there's any other questions, I'll be in the Fortress of Solitude or the unpanel room, whatever it's called. And you can grab me afterwards. I'm always happy to talk about this. If anyone does want to talk about end service bus as well, please. Thanks, everyone.